Okay, so example 3. A particle P moves in the xy plane in such a way that dx dt equals 1 over t plus 1 and dy dt equals 2t for t is greater than or equal to 0. Find the coordinates of P at any time t in terms of t, given that when t equals 1, the particle is at ln of 2, 0. So this problem is really wordy and there's a lot to take in, but the main thing it says is find the coordinates of P at any time t. And this is really important because this means that our answer is going to be in terms of t. It's not going to have just numbers in it. There's going to be t's in it also. And remember that anytime we're given something, it says given when t equals 1, the particle is at, or the position is ln of 2, 0. Anytime we're given information like that, we need to keep note of it and use it in our problem. So we have to split it into the x and y component. So x of t and y of t, we're trying to find that. And note that if it said find the coordinates of P at, let's say, time t equals 2, then this would be x of 2, not x of t, but it says at any time t. So x of t equals x of what we're given, which is the position at t equals 1. We're given that. Plus the integral from what we're given to the value of t that we're trying to find. Well, the value of t that we're trying to find is just t. It's not any specific value. So integral from 1 to t of x prime of t dt. And let's solve this first. So x of t equals, well, x of 1, that's given here, right? When it says the particle is at, that just means the position. And the position of the x component at t equals 1 is ln of 2. Plus, let's rewrite this. X prime of t is the same thing as dx dt. And we're given that dx dt is 1 over t plus 1. So the integral of 1 over t plus 1 is ln of t plus 1, evaluated at t and 1. So x of t is going to be equal to ln of 2 plus, when we plug in t into t, get the same thing, minus, when we plug in 1 into t, you get ln of t, or ln of 2, sorry. And ln of 2 minus ln of 2, well, that just cancels out to be 0. So we're left with x of t is ln of t plus 1. So we found the x component, and now we got to find the y component. So y of t is, just like this one, we kind of use this format. So y of t is y of 1, what we're given. We're given that t equals 1. At t equals 1, the y component is 0. So we're going to use that information later. So integral from 1 to t of y prime of t dt. So y of t equals, y of 1 we just said was 0, plus the integral from 1 to t of y prime of t is the same thing as dy dt. dy dt is 2t dt. So y of t is 0 plus integral of 2t is t squared, evaluated at t and 1. So when you plug in t here, you get t squared. When you plug in 1, so you get 1, so minus 1. So we found the y component, and it said find the coordinates of P at any time t. So the coordinate P is the x component with the y component. And I dropped the absolute value bars because it says in the problem that t is greater than or equal to 0.